Okay, we'll start off with the simplified anatomy of basal nuclei. Basal ganglia it used to be called before, but then right now we has changed as it's a misnomer because ganglia we don't see it inside CNS, so we have named it as basal nuclei. All right, what are the components of basal nuclei? I have an orientation here. Okay, so these are all subcortical mass of gray matter. Like what is it? This what you're seeing in the middle of all is thalamus. Yeah, just just lateral to that you have this white fiber going. This is only called as internal capsule, isn't it? So leaving this thalamus and internal capsule, what we are talking today is basal nuclei. That is these components. I'll tell you what it is. This what you're seeing is the head of caudate nucleus. This is the tail of caudate nucleus. Cut section has been taken like this. Okay, coronally section has been taken, and this has been what you can see here. Caudate nucleus and the tail of caudate nucleus. You have here lens like structure which is convex laterally and more convex medially. This together, as it's a lens like, we call it as lentiform nucleus. Lentiform nucleus. It has a lateral part which is called as putamen and a medial part called as globus pallidus. Globus pallidus. Putamen because it's light stained, hence it is pale like, hence it's called putamen, and this is globus pallidus. And just even lateral to that, can you see a saucer shaped gray matter? This is called as claustrum. Claustrum. So what are the components of basal nuclei? You need to know. Components. Mainly it has corpus striatum. What is it? Corpus striatum. This has two parts. What is it? That is, it is having caudate nucleus and lentiform nucleus. Lentiform nucleus further is divided into two. Can you see here? Lentiform. What is it? It is having a putamen and globus pallidus. Caudate nucleus with putamen, we have a name that is called as neostriatum. Neostriatum. Neostriatum is together with caudate nucleus and putamen of lentiform nucleus. Neostriatum is said to be the afferent of basal nuclei. Globus pallidus alone belongs to paleostriatum. Now this is said to be the efferent of basal nuclei. Did you have an idea? I'll again tell you what all did we discuss right now. We were talking about basal nuclei, having an orientation here in coronal section. Thalamus you are well aware, medial of all. Then we are having internal capsule as the white matter. Internal capsule is between thalamus and lentiform nucleus. Lentiform nucleus lens like, having two parts, lateral part and medial part. Lateral part is called as putamen, medial part is called as globus pallidus. Okay. Very closely related to thalamus, literally encircling in a comma shaped, is called as caudate nucleus. Caudate nucleus. Caudate as in comma. Comma shaped, you remember C shaped. That has a head and a tail, what you are seeing at this level, but you will also have the body, which we are not able to see at this section. Along with it, we also have claustrum, which is a saucer shaped grey matter. Its function is absolutely not known. Now, after knowing this, you need to know what are the components of basal nuclei. Mainly, first component is called as corpus striatum. Corpus striatum has two parts. Caudate nucleus, comma shaped, and lentiform nucleus, the lens shaped. Caudate nucleus with putamen, that is the lateral part, of lentiform nucleus together we call it as neostriatum, which is the afferent, receiving part of basal nuclei. Globus pallidus alone we call it as pallidus, you remember, paleostriatum, which is the efferent, that is leaving from the basal nuclei. Okay, This is the first component, corpus striatum. It also has so many other components like functionally which is related. What is it? Claustrum, I have already told you. Yeah. Third component is called as amygdaloid body. Amygdaloid. Amygdaloid body. I'm sorry, I'm having some issues here. Claustrum, amygdaloid body. Okay, another is substantia nigra, very important component of it. Then we have subthalamic nucleus. Okay, so what are the components of basal nuclei? Mainly we have corpus striatum and its parts. Then we have claustrum, amygdaloid body, substantia nigra of midbrain, you remember, and subthalamic nucleus. Understanding with its function, understanding with its parts. You remember this, what I have drawn like a lens, that is only the lentiform nucleus. Lentiform nucleus. Its continuation is like a comma shaped. Can you see that? This comma shaped black color what I have highlighted is only the caudate nucleus, which has a head here, which has a body here and a tail. If you see this entire caudate nucleus like a C shape is closely related to thalamus, literally encircling thalamus. That is what we were talking here. Okay. Also, this caudate nucleus is in very close relation to one ventricle here that we are seeing is lateral ventricle. Can you see? The head of caudate nucleus is closely related to the anterior horn of the lateral ventricle. Body is closely related to the central part of the lateral ventricle. Okay, tail is literally on the roof of inferior horn of lateral ventricle. So anterior horn, head, central part of the lateral ventricle to the body, and tail is in the roof of inferior horn. This is what you need to understand about caudate nucleus and its relation. Yeah, lentiform nucleus relation is very easy here. Lentiform nucleus is related medially to internal capsule, okay, and laterally it is related to claustrum. That is it. Okay, amygdaloid body. Let me give a moment to that. Amygdaloid body, though it is topographically related, topographically means structurally related to basal nuclei, which part? Tail of caudate nucleus, but functionally it belongs to limbic system. What is it? Functionally it belongs to limbic system. So it has nothing to do with basal nuclei, but structurally, yeah, it is related to basal nuclei. So this is what you need to understand. Next subheading would be function. What you need to understand is, like unlike cerebellum was controlling the fine movements, balance, posture, tone of the same side of our body. Here is just the opposite. This particular basal nuclei and its connection will help us to maintain our crude movements, automated movements as in swinging of our hand during walking. Okay, such sort of movements, the crude movements, coordinating our crude movements is mainly controlled or functioned by basal nuclei. Okay, and which side of our body is it coordinating and controlling? That is opposite side of our body. That's the main thing about function. Now talking about its connections. Very simple item. We'll talk about it. Mainly you need to have an understanding about what I have already written. I have written cerebral cortex, substantia nigra, corpus striatum having two parts, neostriatum and pallidostriatum. Neostriatum is mainly the afferent which you need to understand. So what are the afferent fibers? Okay, I'm sorry for the break. So I was telling about that neostriatum mainly having what? Mainly having caudate nucleus and the putamen. Yeah, together we call it as neostriatum. Now this is the afferent part of our basal nuclei, afferent, receiving part. So it mainly receives from three centers. From the cortex, we call it as with a name corticostriate. Corticostriate fibers. From the substantia nigra, especially pars compacta of substantia nigra, that has a name. I'll write with this. That is nigrostriate. Striate എന്ന് പറഞ്ഞാൽ this substantia striatum, corpus striatum. So corticostriate, nigrostriate. It also receives from thalamus. That is called as thalamostriate. Thalamostriate. Is it easy? So mainly we are talking about afferent here. Afferent, from where all it receives? It receives from the cerebral cortex, so we call it as corticostriate. From the substantia nigra, okay, a lot of disturbance, it's called as nigrostriate fibers. Then it receives from thalamus, especially dorsal medial nucleus of thalamus and the interlaminar nucleus, or the central nucleus of thalamus only it receives from. That is called as thalamostriate fibers. Okay, I need to talk about nigrostriate in particular because it is receiving neurotransmitters that is especially rich in dopamine. Very, very important. Dopamine. Now this dopamine is an inhibitory neurotransmitter. What is it doing? The whatever it is being activated by the other center is literally being put in control by dopamine. When this is depleted only, that will lead to a condition called Parkinsonism. Parkinsonism. Understand? Okay, so this is about afferent. Afferent, where is it going, guys? To neostriatum. From the neostriatum, all the fibers will be going to our paleostriatum, that is globus pallidus. From here, what happens? I'll tell you. The main efferent, now we are going to efferent part, that will be going to thalamus. Thalamus. Now when it is going so, we have something called internal capsule here. Either the fibers will be traversing the internal capsule and going to thalamus, or the fibers will take a loop and go to the thalamus. Now the one which is taking a loop and going to thalamus is called as ansa lenticularis. Ansa means loop, isn't it? Now what is this called as? This is called as fasciculus lenticularis. Ansa lenticularis and fasciculus lenticularis. Going to which main center? Thalamus. Which nucleus of thalamus is this efferent going into? Very, very, very important. That is going to ventral tire nucleus. That is ventrolateral nucleus, I suppose. Ventrolateral nucleus of thalamus. From there it will be going to cortex, cerebral cortex, isn't it? Via thalamic radiation. So this is what you need to understand about the connections. That is it. So afferent is mainly from where? From the cortex, substantia nigra and thalamus. Efferent is mainly going to thalamus. Some of the efferents will also be going to subthalamic nucleus. Don't get confused with these two. Subthalamic, I'll write a subthalamic nucleus, ST. Subthalamic nucleus. Okay, so that is about the efferent. Applied, what the last heading would be applied, you need to understand is Parkinsonism. That is very important. Parkinsonism, you already know right now that these coordinating the gross movements, crude movements, like swaying our hand over when we are walking or showing expressions, all this will be totally lost. So the patient will have some sort of stooped posture, yeah, very short sort of gait he'll be having, that is called as festinant gait. Yeah, and the tremor, like in cerebellum, it was intentional tremor, isn't it? When we are performing some activity, only tremors come. But here there will be resting tremor, this sort of. So it is called as pill rolling movement, this one. So what are the features of Parkinsonism? Mask-like face, no expression, no swaying of wings while walking, stooped posture, that is in a curved right and down. Then what else? Resting tremor, pill rolling movement it is called as. Yeah, and short gait, that is called as festinant gait. Apart from this, we also have other things like A, B, C. This is called as athetosis. B is balismus, and C is chorea. Chorea. Now, balismus and chorea, you need to understand. Ballet is like a dance. Chorea, you need to understand these two will have violent, purposeless, irregular movements. Okay. If it is more involving the trunk, we call it as chorea. If it is involving morely the limbs, it is called as balismus. You remember dance, limbs, proximal part of our limb and all that. Athetosis is slow sinus movement, sinus breathing movement like this. Some sort of, only the fingers will be involved. That is called as athetosis. I hope you understood the attempt and the effort. Thank you so much.